Hello YouTube. In this video we're going to confront how to graph discrete probability distributions. Okay, so let's recall first of all what we mean when we talk about a discrete probability distribution. When we talk about as a given experiment, a discrete probability distribution seeks to find out all of the possible things that can happen and how likely it is for each of those things to happen. So for instance, let's go back to an example I used in my last video. It says let's consider the thought experiment in which we flip 3 coins. Okay, maybe we're interested in the number of heads that we get when we flip 3 coins. Okay, so we had listed out actually the sample space on this one here. We said that there were 8 possibilities. We could get 3 heads, we could get 3 tails. Suppose we could get 2 heads and a tail, or 2 tails and a heads. Could also get heads, tails, heads. We could alternate here, heads, tails, heads. And then last but not least, we could have like a tails, and a heads, or heads, heads, tails. So I have heads, heads, tails. Actually, no, sorry. Got that one backwards, didn't I? This would be a heads, tails, tails, or a tails, heads, heads. But these are our 8 possible outcomes. So for this given experiment, we want to start by defining what we want our variable to represent. So we're going to let x equal the number of heads that appeared when we flipped these 3 coins. So if that's our variable, we're going to start by placing that here and put in the number of possible outcomes. So we could get, when I flip 3 coins, no heads. I could get 1 head. I could get 2 heads, or all 3 coins could be heads. So down here we were placing our probability of each individual event occurring. So for instance, we say how likely is it when I flip 3 coins that I get no heads? And there was only one possibility that provided this. So we had a 1 in 8 chance. How many gave us exactly one head on the coins here? So we could say this one here did. This one here did. And as a matter of fact, I know I've got this one backwards now that I look at it. This is tails, heads, tails. Sorry, I wrote the wrong one there. But we had a 3 in 8 chance of this occurring. Same thing happened with 2 heads. We said 2 heads, 2 heads, 2 heads. So this would be a 3 in 8 chance of occurring. And then last but not least, we say all 3 of them were heads was this last possibility here. So we say a 1 in 8 chance. And recall that all of these probabilities here, if it represents all the possible outcomes, if you add up their probabilities, it should add up to be 1, which we do get 8 eighths when we add this. But that's neither here nor there. In this video, we were talking about how do we graph a discrete probability distribution. So let's start with this. When it comes to graphing these things, we need to place each of these on a given axis. So it's kind of fitting, but we're always going to place our discrete random variable on the x-axis. So this is our discrete random variable that goes on the x-axis here. Okay, and what's going to go on the y-axis then is the probability that that event actually occurs. Okay, so we say the probability that we actually see this happen here. So we've always got x down here and p of x up top. As far as what we put on the x-axis, we notice here for this experiment we had 0, 1, 2, and 3. The nice thing about this is we don't have to put a squiggly here to jump out to our first event here. We're just going to put a 0 down here, a 1 right here, a 2 right here, and a 3 right here. Basically what I want us interpreting this as is this is all possible outcomes. So this is all the things that could happen in this experiment for this given random variable, which was number of heads, and all the number of possible ways the heads could occur. So the y-axis represents the likelihood of that thing happening. So likelihood of each event occurring. Okay, so now we're actually going to have to look at our values of our probabilities here. I noticed that the very, very largest values were like 3/8 here. So we say, well, how far up should I have to go? Well, considering that these are all probabilities, I know some things about them. First of all, they're never going to be negative. So probabilities are always non-negative, okay? And I can also tell you this, all of these probabilities are somewhere between 0 and 1. In other words, each thing that can happen has to be greater than an impossible chance, greater than 0 or at least equal to it, but never over 100%, okay? So to make this graph, here's what we're going to do. We could either, on our y-axis here, where we've got our probabilities, we can convert this into decimals, so we could convert 1/8, 3/8, 3/8, and 1/8 to decimals, or we could use fractions. Since I'm down with the eighths here, we say 1/8, 2/8, 3/8, 4/8 chance. We'll call this our 4 out of 8 possibility here, our 3 out of 8 possibility here, 2 out of 8 here, and a 1 out of 8. But all we're seeking to do is represent how likely it is that each of these things happen. So we're going to create a bar graph for this, and here's what it would look like. We could say my bar here. It's funny that we don't really use a bar. You can use a bar, but I use a line. We say 0 heads. How likely is it that 0 heads happens? Well, I've only got a 1 in 8 chance if I look at this graph here. How likely was it that we only flipped 1 head? And well, 3 of these gave us that. So we've got a 3 in 8 chance. We're going to make our line right here, our skinny bar, our line there, for 3 in 8 chance. We also had a 3 in 8 chance for flipping 2 heads. We had a 1 in 8 chance for flipping 3 heads. So when you look at this right here, this is really just giving us a good idea that when you flip 3 coins, a lot of the time, most of the time, you're going to get either 1 head or 2 heads out of those 3. Not very likely that you're going to get 0 heads or 3 heads. So these graphs are very, very beneficial to be able to construct because you can see the relationship amongst the likelihoods of things occurring. So for this second experiment here, we're going to go back to one I also did in the last video, which was how likely is it that you roll a given number on a die. So we're going to start with this. We say let x equal the number of spots rolled on a die. Of course, we know that a die, if we were to fold it out, looks something like this: 1, 2, 3, 4, 5, 6. Okay. So if x represents the number of spots, what we're going to do is we're going to first of all create our probability distribution, where we say the number of spots that we could get. Well, I could either get 1, I could get 2, I could get 3, 4, 5, or 6. 4, 5, or 6. And of course, if we were to find the probability for each of these all have a 1 in 6 chance occurring. Okay, the probability that you roll any of these numbers individually is all 1 in 6. So we'd say a few things about this. First of all, this is a fair game. This is the reason why it's fair is because everything is just as equally likely to happen as anything else. Okay, and also this: if you were to add up all these probabilities of everything that could possibly happen, it should add up to 100% of our stuff here. Okay, so as far as making this graph goes, we'll just go ahead and throw this together really, really quickly here. We say x is a number of heads. We want to label this here. And we say the probability of x. We don't have to label this, but we kind of just did. But we say it's the likelihood of that occurring. So we say, well, what are all the possible things that can happen? Let's put those down on the x-axis here. So I've got 1, 2, 3, 4, a 5, or a 6. A 1, a 2, a 3 could have happened. A 4, a 5, or a 6 could have happened. And then on my y-axis here, I noticed that it only goes up to like 1/6. Okay, that was my highest probability. So in order to put this on my y-axis here, we could convert these all to decimals, by the way. That is 0.166 repeating, or 16.66%. I find that it's going to be easiest if we do this in sixths. So we've got a 1 in 6 chance. We'll call this a 2 in 6 chance, and I know that's a third. Or we'll call this a 3 in 6, and I know that's a half. But we're going to leave them the way they are. What I want us to see is that every single thing that can happen on a die has an equally likely chance of occurring. So we say, well, what are these graphs really good for when I graph a probability distribution? Again, we can easily see which things are more likely to occur than others. Okay, so probability distribution graphs, really nice to have, especially outside of theoretical instances like we have dice and coins, where we might be talking about a business. Okay, so that's going to be our next stop, is empirical probability distributions. Cheers.